Hello, everyone. We are here to talk about our journey in realigning our engineering function and how we use cognitive load to guide that. But first, who we are. We are from Mimecast. It's a leading provider of email security, and we work in the business unit that focuses on email security, covering about 150 engineers for the period we'll be talking about. My name is Burak Cetin. I'm a senior engineering manager looking after software development teams responsible for security scanning and related product development. I'm nearing about 4 years at Mimecast now. I have a background as a software developer for about 15 years before moving into management about 6 years ago.
My name is Graham. I'm a senior principal engineer for email security. I've been at Mimecast a little over 10 years, varying from engineering to management, and then settling back to being a technical engineer or an architect again. So to start the journey, I'd just like to talk about what Mimecast were like 4+ years ago. So back then we had a series of DevOps component teams, and each of those component teams owned one or more functions, for example, a mail transfer agent or a UI admin console. And they got very good at that. That was their purpose. They had autonomy to change it. And they were the ones that had to get up at 2 a.m. in the morning to fix it if it went wrong. And we like to call that motivation. The trouble is that products were distributed across those components. In the worst case being one product actually touched 15 of them. And that meant those products actually touched quite a few teams. Now, when that happens, you end up with each team has a little window into that product, but no one really understands the whole thing end to end, except maybe a product manager or an end-to-end tester. That also meant that all the products, because Mimecast had quite a few of them, were making these component services quite large. So even the component teams themselves didn't fully understand exactly what they were dealing with. One of the biggest problems, though, is silos. So while we're developing products, that was fine because people were talking to each other, but afterwards, they don't talk at all. Communication tends to be done via Jira tennis, which is not the most efficient way of doing things. And it's difficult to coordinate. There's a large overhead on the dependency mapping every time we want to start a new development, as we try and figure out what teams that's going to touch. Worse still, delivery times become unpredictable. If any one team has an issue, then the whole product is delayed. So there's a lot of risk there. So the first thing we try to do is realign people from component teams into product teams. These teams were designed just to be given a product and then work on that product end to end. They were cross-functional. They contained a mix of the people from the component teams as best we could get them. And they were given delivery managers to kind of help with that. And they operated kind of using some Scrum techniques. Unfortunately, there were still some special cases. Some products didn't lend themselves very well to these kind of teams. So we had these component teams that existed, and they would lend engineers into the product teams, but they would then pull them back afterwards. And that meant the teams never really gelled together because there was too much change. Another problem we had was cognitive load. So cognitive load is defined by John Sweller as the total amount of mental effort being used in the working memory. And there are 3 types defined. Intrinsic is the basic day-to-day operations. So for an engineer, this might be how to write Java. Extraneous are the things that a team shouldn't need to know, but generally end up having to. Things like how the build process works. And germane is the important bit. That's the bit that actually allows them to do what they've been tasked. So for example, the techniques to do with phishing detection. And we want to maximize the germane and completely eliminate the extraneous. But we've got too much of this right now. We've got these teams that are handed a product, and then afterwards they're going to be handed another product. So they kind of own a bit of everything. And that means they've got too much germane knowledge to learn because they've kind of got to know about every single product. Worse still, they've also got extraneous because they've got to know about every single component they're dealing with. And that's stuff they really don't need to know. We also have lost ownership on the component services. So the people getting up at 2 in the morning and fixing them are not the people that are working on them anymore. And that generates resentment and is not the way things need to be done. So ultimately, we've got a case of we don't know who's responsible for these component services anymore, and that leads to stability suffering.
Let's take a few steps back. I want to tell you about how we were introduced to this concept of cognitive load from a book called Team Topologies. It's from Matt Skelton and Manel Pai, and it was actually a prompt from our common manager that led us into reading this book. We found that the book was insightful about teams in several ways, advocating a team-first philosophy. But our main takeaways were really understanding cognitive load, the importance of end-to-end ownership by teams, and that really not all the teams are the same, which was a mistake we did before. The Team Topologies approach allowed us to focus explicitly on the customer. Instead of talking about component services, we started talking about products and features and end-to-end usage. This had us looking at things like our sales and marketing documents and our customer support organization to understand how they saw our software. This then led us looking at splitting ownership across domains defined along these lines, such as products and features, instead of components. But a key thing to understand here is that not all teams can be customer facing, and there are different types of teams in a software organization. The Team Topologies approach explicitly identifies 4 different types of teams, and so matching domain types. Let's start with Streamline, which is the bulk of them. It's about a product, a feature set, something you may call a business domain. It can also relate to things like targeted user personas or a special geography. Then we have the enabling teams. These are specialists that help a team improve an aspect of their software. This may be about monitoring and alerting or setting up a good build pipeline for them. Then we can talk about complicated subsystem. It's a software component in the traditional sense. It's a reason to keep a software component team because the software may be too complex to be broadly understood. It may be legacy software that's hard to rewrite. Then we have the all-important platform teams, which are there to provide all the necessary backing services so that customer-facing teams that they have everything they need to deliver the end-to-end results, but without being pushed to cognitive overload. In a way, platform teams are like customer-facing teams, but for internal customers, helping them succeed in turn. You may expect about 80% of the teams to do stream-aligned work in a typical organization and 20% for the rest, which was our experience as well, as we'll detail. Let's see how this comes together. Say we have a DevOps team looking after domains such as URL protection. This is identifying malicious URL in an email. This is a customer-facing domain and is typically led by a product manager. Being a customer-facing team, this team may lack specialist knowledge on how exactly an email is to be parsed. You would have experts who have in-depth knowledge about the relevant RFCs and the security concerns who would have this kind of knowledge. They then are the complicated subsystem team. They are providing a software component that helps with the email parsing to the other team. And the stream-aligned team may need help from someone to improve their monitoring systems and help set up an on-call rota for them. That would be an enabling engagement. Finally, the team may need the services of a resilient email archive to continue to support detection in historical emails. And that will be provided by a platform team. And now you can see how several teams come together to have that one stream-aligned team so that a single team can successfully own and deliver the important business function that is URL protection, end-to-end, and without being cognitively overloaded. Moving on, we started a process of reassigning ownership back to the teams. This had us identifying all the domains and deciding their types, such as customer-facing streams, which are end-to-end, or platform. We worked with the engineers to find these out and had discussions of what domain was what type. We also went through a lengthy process of measuring cognitive load, assigning inherent software complexity measures by domain, such as low, medium, high, like you would assign a story point to a ticket in comparative terms. We looked at the number of support cases being raised per domain. We looked at the product roadmap to understand the planned future changes and map them to the domains. All these combined together give us a measure of how much cognitive load the ownership of a domain imposes. To put this in a formula, we would get that the cognitive load is equal to the inherent complexity times the expected change for that domain. We want to give each team a set of domains that will impose a similar level of cognitive load overall. We want these domains to be a coherent set together and similar types such that we can identify a team, for example, as a stream-aligned or a platform team in the end. We also want these domains to create a steady stream of work, giving the teams longevity. Ideal is that each team has one high cognitive load domain, but in some cases, we gave several low to medium-sized domains to a team instead. We made use of tools like Trello. You can see in the background there in the picture, to do this assignment and assigning these domains to the teams back and front, and trying different arrangements. We found in the end that the reality was that a typical team received about 3-4 domains, and that we were very close to the 80% mark in the number of teams in the end that were stream-aligned.
So one of the other things we wanted to do here is push our architecture away from these component-based services. Now, we've read of something called Conway's Law, which is organizations design systems that mirror their own communication structure. And that's exactly what we'd had. We'd had component-based teams that had produced components that those teams owned. And we wanted to move forward. We wanted domain-level services that were far smaller and easier to manage. And we were hoping the new team structure could drive that. And this is apparently called an inverse Conway maneuver. So an example of what that looks like, if you have a mail transfer agent, which has a domain called attachment protect in it, and you have a stream-aligned team that owns attachment protect. The idea being is to take all the code, take it out of the MTA and create a service around that. They own the service from the UI end all the way to the back end. So they also work on a UI module. Now, we don't want these guys to be UI experts because that's extraneous knowledge. So they work in a UI framework, which can be provided to them by a platform team. And that UI framework can be used in the same way by other stream-aligned teams that work with their own domains.
12 months after rolling out the domain model to our engineering group, we circled back to see its impact. We conducted interviews with the various stakeholders, such as product managers, engineers, and the delivery managers, to hear what they had to say. Product managers were generally receptive and sometimes even enthusiastic, despite being the group with the biggest initial reservations. Engineers were happy to be finding more time for engineering investments, and in general, better clarity about ownership. Delivery managers were happy to see that the teams were creating stronger identities, and there was a sense of ownership compared to the past. One common theme of complaint was around relative loss of flexibility. This is both in terms of planning of future work and the variety of work on offer for the engineers. We also conducted a survey in the engineering group to see if the move to using domains made them happier. A majority of them told us that their lives were made easier and they were happier with the domain model.
So to summarize some of the things that we think went well here, firstly, from a reaction point of view, it's generally positive. Even the more hard-boiled, surly engineers kind of like this. One even defended it, which was a huge shock and joy to us. Product management were happy too, and that was good because, as Burak said, they were initially one of the more reticent people regarding the move to this model. A lot of the issues that were highlighted from the survey are actual problems with our implementation or our communication, and these are entirely fixable. So these are something we can actually do something about relatively easily. And finally, the teams understood their roles. They understood their role in the company and what they needed to work on. So some of the main benefits we've got, we have ownership. The teams know what they own, and they know they're owning it in a year, which means they have a vested interest in making it good and making it stable. More than that, they know what other people own as well. So if they have questions, they know where to take them. We see a reduced cognitive load. The teams can forget about products they're not working on. And a lot of the teams were very happy to forget about those products. So we still got silos between teams. They don't communicate as well as they should. But for an individual product domain, that's now held entirely within the team. And the teams are talking with itself quite happily. So we've kind of resolved that problem as well. And finally, this whole model is customer focused. All the teams that aren't stream aligned work to service the stream aligned team, and the stream aligned team work to giving the customers the best possible service. And that aligns directly with Mimecast's vision.
Let me take you through the things we know that we need to work on. We have seen that the new domain model indeed pushed us to a new architectural direction through the effect of Conway's Law, but we saw that this needs to be supported to move forward. Full adoption eventually requires all departments to buy into the domain model. This includes those teams providing platform services. And also alignment is needed with teams looking after things like customer escalations, even service delivery. Domains need to be a living effort, with the new domains emerging, others needing modifications, consolidations of multiple domains, or retirement. Loss of flexibility needs to be managed as well. This may involve things like arranging for temporary moving of engineers or moving of suitable projects across team boundaries in critical cases where time is essential. Also managing the growth of engineers more proactively by exposing them to a variety of work. We want to take a little time to reflect on our 18 months of experience from our start of our Team Topologies journey to nowadays. As a manager, I see that there's an expectation in our industry that long-standing cross-functional teams is the winning formula. Our experience, however, was that in our particular situation, perhaps due to a large portfolio of products on an existing user base, some problems persisted in this setup for us. Team Topologies approach gave us an incremental path forward that fixed those new problems without losing the benefits of the earlier efforts. This, in effect, allowed us to continue using the new cross-functional teams. What was interesting was that we had very little, if any, resistance from engineering, and the resulting setup appeared to make both product and engineering relatively happy in the end. We feel that the benefits we gained relate to Team Topologies being empathic to the concerns of a software engineer, such as cognitive load or service ownership.
So from my perspective, one of the things that actually won me over with this model is it becomes very easy to reveal investment. Now, there's a couple of points to this. Firstly, you can see from the domains the teams own which teams are overloaded, and you can do something about it. On top of that, the analysis of the domains also show what domains are generating more support calls. So that, again, leads you to know where you need to point some engineering effort to fix. But lastly, it allows us to also demonstrate investment to the business as a whole. So we had a situation where the business wanted us to invest in a particular domain. And it's actually relatively easy to demonstrate that because we spun up a new team which owned that domain and we recruited explicitly into it. And we were able to demonstrate that. I mean, we've mentioned far too many times probably about cognitive load, but it was a real gain for us. The teams do not need to know half of what they used to have to know. They can concentrate just on the bits that are important to them. And one final point is that we adopted the pieces here that we wanted to based on our needs. For those that are interested, there's a lot more in the book, and it might be interesting to go and look into that.